Hi y'all. In this video we're going to look at 5.1 on multiplying and dividing rational expressions. To begin with, we're going to review some corresponding problems that involve real numbers that are also covered in section 5.1 of the text. As we go through all of the examples in this video, I would recommend very strongly that you try the problems yourself first before going through the video and watching it. As you go through the video, make sure you're correcting any problems that you had and making sure that you did the problem right. To simplify 18 over 30, I'll note that we can factor this as 6 times 3 over 6 times 5, which is equivalent to writing 6 divided by 6 times 3 over 5. Well, 6 over 6 is just 1, so this is 1 times 3 over 5, or 3/5. And that's simplified. In general, the rule for this kind of problem is if I have an expression of the form a times b over a times c, I can simplify this down to just b over c. Now, the original way I had this written, it didn't look like it was in this form, but it really was. So that's what I did in the problem. I rewrote it so I could see that it was really a times b over a times c, where a here was 6, and I got this final answer of b over c. In later examples, we're going to see variables in the places of these numbers, and we want to be careful about something. In the expression I have here, I know that a and c cannot be 0 because that would make the original expression undefined. I want to avoid that sort of thing, so I need to add into my rule that a and c both cannot be 0. Alright, so going through this, let's look at this slightly differently. I could have done the problem a little bit differently, and taking that 18 and finding its prime factorization, so kind of looking at a factor tree or something, because seeing this as 2 times 9 or 2 times 3 squared. So the original 18/30ths, doing that with 32, I would have gotten something similar. So it's 2 times 3 squared over 2 times 3 times 5. If I break it down into prime factors, I will always be able to end up seeing all the prime factors that will cancel out and be left with a series of prime factors, or in this case just 3 and 5, which are both prime. I've simplified something when I get this down to prime factors, or prime factors in the numerator and prime factors in the denominator, none of which can cancel out. So that's what simplification will look like, and that's what I have here on example 1. Looking at example 2, I'm asked to multiply the following fractions and then simplify. So to start off with this, I'm first actually going to factor these conveniently. So 56 is 7 times 8. I chose to write it that way because, hey, I got a 7 down there. And I got a 7 times 15 is 5 times 3. I'll do a similar thing to the last time. I have 5 times 7 over 5 times 7 times 8/3. Well, 5 times 7 over 5 times 7, that's 1. 1 times 8/3 is indeed 8/3, which is my simplified result. I didn't write 8/3 as 2 cubed, which is its prime factorization, but 2 cubed has nothing in common with the 3, so this is my final answer here. In general, the rule for this particular kind of problem is that a divided by b times c divided by d is ac over bd. Again, I need to pay attention to the domain. Here, b and d cannot be 0. What I did from there with this problem was I conveniently put it together with the first rule, and that was I worked to cancel out things that I could. And that's what we're going to want to do on problems of this sort. Example 3 asks us to define the following fractions and simplify. And before doing that, I'm actually going to look at the general rule for this sort of problem. When I have an expression of the form a divided by b divided by c divided by d, that is a fraction divided by another fraction, this is equivalent to multiplying the first fraction by the reciprocal of the second. So I'm going to end up with the result of AD over BC. Now here, the domain, I'm going to write my domain in purple. Well, I can't have B be 0 because that would have made the first fraction undefined. I can't have D be 0, that would have made the original second fraction undefined. I also can't have C be undefined, 0, because that would have made this part of the fraction undefined. So all of B, D, and C cannot be 0. Now back to our original problem. What we just said was I can rewrite this as 3/10 times 25/12 Well, let's break that down so we can cancel out common terms. This is 3 times 5 times 5 over, well, 2 times 5 times, well, the 12 is, I can write this in several different ways. 2 times 6 is one of them, or something like 3 times 4. 3 times 4 is the more convenient one to write it here because there's a 3 I can cancel here. So I'm going to go through and notice there's a 3 here, a 3 here, a 5 here, a 5 here. And I'm left with 5 in the numerator over 2 times 4. If I didn't have any expression left at all in the numerator, that would be the equivalent to multiplying whatever numbers got canceled times 1 over whatever my denominator was, and that 1 is what I would be left with. So be careful about that. All right, example 4. This is a fundamentally different question. It asked me to find the domain. Well, throughout this video, I'm going to use purple for domain. So let's use purple here. The domain, well, it's going to deal with where the denominator is 0. So I'm going to be concerned with the denominator only. In this problem, I know that 5x plus 15 can't equal 0. Well, that's going to get at what the x values can or can't be. So let's solve this for x. We'll start by dividing both sides, or rather subtracting both sides by 15. Rather, subtracting 15 from both sides. So 5x shouldn't be a negative 15. Dividing both sides of that by 5, we see I'm running out of room, but x should not be negative 3. So the domain should be the set of all x so that x is not negative 3. Looking at b, again I'm going to focus on the domain. Very nicely, this is already in a factored form. So x minus 2 times x plus 7 should not equal 0. Setting each part equal to 0, which is what the 0 property of multiplication allows me to do here, I should get this as x minus 2 shouldn't be 0, or x plus 7 shouldn't be 0. Adding 2 to both sides in the first expression, I'll get x is not equal to 2. Subtracting 7 from both sides in the second expression, I'll get x is not 7. So those two things together make my domain. Let's write it all together over here. Domain should be x is not equal to negative 2 or negative 7. And by negative 2, I of course mean positive 2. Sorry. We'll just erase that negative there. So x should not equal 2 or negative 7 is my domain for b. We'll go on to the next one. In example 5, we're told to simplify, multiply or divide the following rational expressions, as well as find their domain. Your final answer should be simplified. I'm going to reiterate, please attempt to do each of these problems yourself before watching the video. Many of these will involve extensive factoring from chapter 4, and I will typically write down the final answer and not a whole lot of the work. Please review chapter 4 before you get into too many of these problems, but make sure that you go along with what's in the video and you're getting the answers that are here, as these are the correct answers. Alright, so looking at A, hopefully you're noticing that both the numerator and the denominator will factor here. So let's go ahead and do that. So the numerator is going to factor into x plus 5 times x minus 3. And the denominator will factor into 2x plus 3 times x minus 3. Using some of our ideas from before, we should see that these x minus 3's are in common and therefore will cancel out. And we should be left with a simplified form of x plus 5 over 2x plus 3. Now looking at that closely, we're going to see in the numerator and the denominator have no common factors. Further, we're going to notice that both x plus 5 along with 2x plus 3, those are both prime factors. That being the case, this is simplified. Now, we didn't answer all of the things we were asked to in the question. We also want to find the domain of this expression. The domain is going to relate to, in this problem, where the denominator isn't 0. This was the original denominator, which was exactly equivalent to this factored form if I did the factorization correctly, which hopefully I did. And this factored form, the 2x plus 3 times x minus 3, is much easier to work with, so we're going to work with that. So 2x plus 3 times x minus 3 can't equal 0. I'm going to set each part of that equal to 0 and solve each part. So 2x plus 3 shouldn't be 0, or 2x minus 3 shouldn't equal 0. Looking at the first expression, subtracting a 3 from both sides, we'll get 2x is not equal to negative 3. Dividing both sides by 2, we'll get x is not equal to negative 3 halves. For the second expression, adding a 3 to both sides, we'll get x is not equal to 3. Putting that together, the final domain should be x is not equal to negative 3 halves or 3. And that's the other part of my final answer. Part B, got the expression x squared plus x minus 6 divided by 3x squared minus 7x equals plus 2. Let's go through this. So factoring the numerator, again try this yourself before you look at this, is x plus 3 times x minus 2. The denominator should factor to 3x minus 1 times x minus 2. Similar to the last problem, we get these x minus 2's to cancel out, and this is going to simplify down to x plus 3 divided by 3x minus 1. I'll add, when we get down to one term in both the numerator and denominator, I don't need parentheses there by themselves anymore. And since both x plus 3 and 3x minus 1 are prime, linear terms by themselves are usually prime, unless they have a common factor or a common term. This is my simplified form. Just need to find the domain with this. As with last time, I'm going to start with this factored form over here. So for the domain, I'm going to really be doing just like I did over there. I'm going to be setting each of the individual terms and not equal to 0 and determining where they're not equal to 0. So let's just do that. So adding 1 to both sides here, we'll get 3x can't be 1. It should be a positive 1. Dividing both sides by 3, we'll get x cannot be 1/3. Looking at the second expression, adding 2 to both sides, we'll get x cannot be 2. So the domain of this should be that x cannot be 1/3 or 2. Alright, and that's A and B. Example C is a little more complicated, but we're going to do the same basic thing. Again, please try the example before looking at the video. Here, let's make sure I got the right pen. I notice a squared minus b squared is a difference of two squares. So I'll in fact write this as a plus b times a minus b. And as I'm multiplying, I'll go straight across and keep going. 10a plus 5b has a common factor of 5. It's the greatest common factor, in fact. So it should be 5 times 2a plus b, all divided by, well, in the denominator, the first expression I see is that 10a squared minus 10ab. The greatest common factor there should be 10a times a minus b. And going across, the 2a squared plus 3ab plus b squared factors to be 2a plus b times, let's see, this should be a plus b. Right now I want to go through this expression and look for common factors that cancel out. I got an a plus b here, an a plus b there, a minus b, 2a plus b, 2a plus b. Let's write down what I'm left with. I got 5 over 10a. Whoops, looks like they have a common factor as well. This is 5 times 1 over 5 times 2a, so I'm left with 1 over 2a as my simplified expression. And that is the simplified expression. And if I stopped there, I would have missed part of the problem because I didn't do the domain yet. Alright, and again, the domain relates to where the denominator, to what the parts of the denominator that can't be 0. So let's look at all of this. Here I should see that I have 1, 2, 3, 4 terms to deal with. I'm going to look at where each of those is not equal to 0. 10a can't be 0, a minus b can't be 0, 2a plus b can't be 0, and a plus b cannot be 0. Alright, so 10a is not equal to 0. Well, getting the a by itself by dividing both sides by 10, I should see that a cannot equal 0. Looking at that problem, I frequently get asked things like, well, what about 10? Well, I could have written this as 10 can't equal 0, along with a can't equal 0, and that would have been correct. I'll notice, let me look at that very closely real quick. 10 can't be 0. That's always true. That doesn't do anything to change anything about the domain. That's just always true. These constants aren't going to affect the answer when they're products, that is, they're being multiplied out there. So that's not going to change anything about the domain. Looking at the second expression, I'll get this solved for a, so I'll add the b to both sides. So I should see that a can't be equal to b. From the 2a plus b term, I'll subtract the b from both sides. I'll get 2a cannot equal negative b, dividing both sides by 2. We'll see that a cannot equal a negative b over 2. And the last expression, I'll subtract a b from both sides. So a cannot equal to negative b. So I have 4 parts to this domain. Try to write this out. The domain involves a not equaling 0, b, negative b over 2, or a negative b. And that's my domain. So now I've simplified the expression. I have no common factors between the 1 or the 2a, and I also determined the domain. Looking at this next problem, kind of more of the same. I'm going to factor everything in the numerator and the denominator and then cancel out what I can. N squared minus 9, that's a difference of 2 squares. That 9 should be 3 squared, so this should be n plus 3 times n minus 3. The n plus 2 nicely looks factored all by itself already. For the denominator, the n squared plus 5n plus 6, it's going to factor to n plus 3 times n plus 2. And the 6 minus 2n, well, that should be, I got a 2 in common. So let's factor out the 2 times 3 minus n. All right, let's go find some common things here. I got an n plus 3, n plus 3, n plus 2, n plus 2. I'm left with an expression that looks like n minus 3 over 2 times the quantity 3 minus n. Alright, now this may look like it's done, but we're going to see that it's not, and we will be real careful with this. So we're going to continue on this problem, but before that, again, try to simplify that. See if you can see what it is that we can simplify here. Alright, welcome back. Let's see what we got with this. Now, I'm going to point out something, a negative 1 times a negative 1 is just 1, and it's always okay to multiply things just by 1. So let's rewrite this a little bit. This is the same as n minus 3 divided by 2 times a negative 1 times a negative 1 times 3 minus n. And you won't always have to do this because we're going to get a general rule out of this, but let's just keep going with this and see what happens. So that denominator, we're going to do something kind of funky. I'm going to group those negative 1s now. I can group that part, and I can group this part. Well, that's going to be, well, a negative 2 from the first group times, distributing in the negative 1, I'll have, well, it's a negative 3 plus n. Okay, so this is equivalent to writing n minus 3 over negative 2 times, well, negative 3 plus n, that's the same as n minus 3. And now we see what's going on. We're going to have these n minus 3's cancel. All right, and to be clear here, I want to point out this is n minus 3 times 1 in the numerator, so I'm going to be left with that 1. So this whole thing is going to simplify down to 1 over a negative 2 or a negative 1/2. That's simplified down a lot. All right, the general rule for things that look like this. Let me write out the rule. You will want to write this down in your notes. You will need to know this. You will see expressions like this again. And I'll kind of say it like this. I would expect that most of you will do it kind of like this. You'll see the things that cancel out, obviously, the n plus 3, the n plus 3, the n plus 2, the n plus 2. Those all canceled out. That was pretty clear. You need to look carefully at the expression you get. It's okay if that's not your final form, if you have somewhere further to go. But you need to look for things that look like a minus b over b minus a, because that's always going to simplify down to just a negative 1. So when you see that, I could have just short-circuited this right at this point. I could have said, oh wait, those two things are of that form. They're like a minus b over b minus a. Well, that's just going to be a negative 1. I'm left with a 2. I could have done that right then if you know this rule. And that would lead you to the correct answer. Alright, so that's the simplified form. Let's do the domain real quick. Again, we're going to set each of the terms in the denominator equal to 0. There are 1, 2, 3, 4 terms. So I'm going to find out where n plus 3 equals 0 and exclude that. N plus 2, I don't want it to equal 0. 2 shouldn't equal 0. Let me write that up here. 2 doesn't equal 0. Yeah, that's always true. I don't really need to worry about that. So there's really 3 terms to worry about. And 3 minus n should not equal 0. Looking at the n plus 3 doesn't equal 0, I'll subtract the 3 from both sides. I'll get n shouldn't be negative 3. Subtracting a 2 from the second term, I'll see that n should not be negative 2. Adding the n to both sides, I'll see that 3 should not be n. So I should see my overall domain is n does not equal negative 3, negative 2, or 3. And that's my domain, and that's D. Let's go on to E. In E, we see that we're dealing with a fraction divided by another fraction. So let's look at rewriting this just to see another way to write this. So this is the equivalent to 45z to the fourth over 7y divided by 5z divided by 21y squared. Well, from one of our rules before, we see that this is equivalent to 45z to the fourth over 7y times 21y squared over 5z. Now, our goal at this point is to be looking for things to cancel out. So I'm going to factor things conveniently. That is, I'm going to factor them to try to get these things to cancel out. Looking at the 45z to the fourth, I don't see much in common with it in the 7y. So let's look over here at the 5z. I think I do have a 5z I can factor out of the 45z to the fourth. That'd be 45z to the fourth, that'd be 9z cubed. So 5z times 9z cubed is 45z to the fourth. Doing the similar thing with the 21y squared, well, it's got a 7y. I can factor that out. That'd be 7y times 3y. And this is all going to be divided by 7y times 5z. And I see some things canceling out. And I'm left with, nicely, prettily, 9z cubed times 3y, or 27, that's 9 times 3, times, we usually do this in alphabetical order, yz cubed. And that's my simplified part of the expression. I need to do the domain. The domain here. Looking back at my rule, it said I need to be careful about where this is 0, this is 0, and this is 0. Okay, so I need to make sure that 7y does not equal 0, 5z, let's try that again. 5z is what I meant to say. 5z shouldn't be 0, and 21y squared shouldn't be 0. Looking at this first expression, 7y doesn't equal 0. I need to get rid of the 7. I'll divide both sides by 7 and be left with y does not equal 0. Second expression, I'll divide both sides by 5. See that z should not equal 0. The third expression, I'll start by dividing 21, both sides by 21. I'll get y squared doesn't equal 0. Taking the square root of both sides, it should be the plus or minus square root, really. I'll get y is not equal to a plus or minus 0, which is just 0, which I already had. So this was actually redundant, so I don't need that expression as part of this. But the domain here, I'll just circle what I already wrote. Wow, I missed. The domain involves y not equaling 0 along with z not equaling 0. So that's my domain. I've got my simplified expression over here. That's how we do E. Looking at F. Alright. So again, I have a fraction divided by another fraction. So this should be p cubed minus 8 divided by 5p squared plus 15p. And again, work this out before you go any further. Times the reciprocal of this initial fraction down here. So I'm going to multiply it by p squared plus 3p. You can write out that extra division step, that's fine, and then have this as your next step. That's perfectly okay to do. Or you can do it all in one step. Alright, as we go through, I'm going to factor each of the terms that I can. I should note that the p cubed minus 8 is a difference of 2 cubes. That is p cubed minus 2 cubed. This was one of those special factors. You may want to re-look at that. This will factor to be p minus 2 times p squared plus 2p plus 4 times p squared plus 3p. That has a p in common. So p times the quantity p plus 3 all over, well, in the denominator, that first term on the left, I can factor out a 5p from each of those terms. I'll be left with p plus 3. That second expression, again, this is one of those special forms. This is a difference of 2 squares. P squared minus 2 squared. So this will factor to be p plus 2 times p minus 2. All right, and I want to make one more comment before I go any further. This term right here, p squared plus 2p plus 4, that's what you got from factoring the difference of these 2 cubes. All right, when you factor a difference of 2 cubes like this, it turns out that this expression is actually prime. What that means is it's not going to factor into any linear terms. So unless I have exactly that term somewhere else in the problem, it's probably not going to factor. It's almost certainly not going to factor. So let's look at the other things that I've got here. I have p minus 2 in common. I have a p plus 3 in common. If I look really carefully, I see this p here and this p here, so I'm going to cross those out because they were in common. I'm left with in my numerator, let's see if I can get everything. This is p squared plus 2p plus 4 divided by, in the denominator, 5 times p plus 2. And as each of those 3 terms are prime, that's my simplified expression. Looking at the domain, again, I need to deal with this term, and this term. And it's preferential to use the factored form. So I've got all this stuff down here along with this over here. Those were the factored terms that were associated with these terms over here on the left. Okay, so I need to set 5p equal to, or determine whether that's not equal to 0. I need to determine the p plus 3. That can't be 0. I got p plus 2. That can't equal 0. P minus 2, that can't equal 0. So this is all the denominator on the right here. Now let's look back up here at this part up here. I got a p and a p plus 3. Well, the p plus 3 was already written down. I don't need to do it twice. This 5p, it's got the p as well. So I don't need to do either that part of that. In fact, the parts that cancel out, I don't need to do redundantly. I don't need to do more than once. But my domain can be found just looking at these 4 terms. So here I should see that p can't be 0. Subtracting a 3 from both sides in the second expression, I'll see that p can't be negative 3. Subtracting a 2 from both sides of this expression, p can't be a negative 2. Adding 2 here, p can't be 2. So my domain is the set of all p so that p is not 0, negative 3, negative 2, or 2. And that's F.